In this video, we're going to look at the mean and the standard deviation for a normal distribution and the probabilities that are associated with them. And we're going to start by looking at the 68, 95, 99.7% rule. Now, for all you further students, I need you to know that these are in fact rounded values. Okay, you can see already here that it's 68.3. and it's 95.4 and it's 99.7. So we need to be making sure that when we're working in methods, that if it asks for approximate values, we're okay to go with our further knowledge. Otherwise, we need to be a little bit more exact. For everybody else, let me explain how this works. So our mean for our normal distribution sits under the highest point of the curve. Also our mode and our median. Now, if we went from here and we go out one standard deviation in each direction, we find the point of inflection of the curve. We already know that one. There's our point of inflection. But what we also find is that in between whatever value it is here, say that was a 3, and whatever value it is up here, say that's a 5, what we have is that approximately 68% of our data value lies within this space here. So whatever the values are in here, between here, say this is, I said it was a 3 and a 5, then then 68% of x values are between 3 and 5. If we go out from the mean in this one, if we go out 2 standard deviations, so one standard deviation out this way takes you to here, and then if we go out another standard deviation here, so that's a sigma and a sigma, what we get is the mean plus 2 standard deviations. And if we do the same in the other direction, we get to this point here, and what you have is that between these two values, let me just say this is 2 and 6, then what you have here is that 95% of your x values are in between 2 and 6. And then if we take that one step further and we go out a 3rd standard deviation, so 1, 2, and 3 standard deviations this way, we end up with 99.7% of all of the values fitting in between those two values. So say that was a 1 and a 6, then 99.7% of all the values, all the x values, are between or equal to 1 and 6. So let's look at an example. X is normally distributed with a mean of 10 and a standard deviation of 2, with a mean of 10 and a standard deviation of 2. Find the range between which approximately 95% of the values lie. Approximately 95%. So to contain 95% of the data, we have to go out from the mean, we have to go out 2 standard deviations. So I'm just going to whip myself up a little bell-shaped curve here. Doesn't really matter the shape of it. I'm going to pop my mean in as 10, and I'm going to put my standard deviation as 2, which means that I'm going to go out 2 this way to here, which will make this the number 12, and then another 2 out this way, which will make this the number 14. I'm going to come 2 in the other direction, which will bring me to 8, and then another 2 this way, which will bring me to 6. So now I am 2 standard deviations from the mean this way, and 2 standard deviations from the mean this way. So my 95% of my values are going to be between these two. So the range is 6 is less than or equal to x is less than or equal to 14. That's the range of values that I'm looking for. The second thing we're asked to find is what approximate percentage of values lie between 8 and 12. So if I use my graph again and I draw it on, oops, that's not very good, doesn't matter, just a sketch for me to work out what I'm doing. So this should be our mean, which will be 10. Our standard deviation is 2, which means 12, 14, 8 and 6. So we're asked for what percentage lies between 8 and 12. And so those two values are, this is the mean minus 1 standard deviation, this is the mean plus 1 standard deviation, and that is our 68%. So approximately 68% of the values lie between 8 and 12. Let's have a look at a different example. Find the mean and the standard deviation for a normally distributed variable where approximately 95% of the x values lie between 25 and 40. So we need to find the mean and we need to find the standard deviation. So we know it's normally distributed, so what I'm going to do is I'm going to draw my little bell curve. Don't worry, you'll get good at drawing them. And we need 95% of the values to lie between 25 and 40. So for 95% of our values, we are from the mean, we are 2 standard deviations out. 1, 2, 1, 2. And what we're going to have is that these values are 25 and 40. So 25 and 40. Okay, so the first thing we're going to be able to find is we're going to be able to find the mean. Because it's symmetric, the mean is exactly halfway between these two values. So what I'm going to do is I'm going to add those two values together and divide by 2. So it gives me 65 on 2. So my mean is 32.5. Easy, put that in. 32.5. So now I need to figure out what my standard deviation is, and I know that the mean plus 2 standard deviations will get me to 40. So if I write that down, the mean plus 2 standard deviations is equal to 40. Now the mean we just found out was 32.5, plus 2 standard deviations is 40. So 2 standard deviations is 40 minus 32.5. So 2 standard deviations is 7.5. So our standard deviation is a half of 7.5, which is 3.75. And our mean was 32.5. So here's a couple of examples for you to have a go at. So press pause, have a go at the questions, and then come back and compare your answer to what I got. So for the first one, I got B. For the second one, I wanted to just show you a different way to work through this or think through this. You may or may not have done it this way. So that we've got here that the variance is 16. So sigma squared is 16. So our standard deviation is 4. So if we had over here 95%, that means that we have 2 standard deviations to the mean and 2 standard deviations to the other number. So we've actually got a total of 1, 2, 3, 4 lots of the standard deviation here. So this distance, if this is correct, should be 16. Now 84 plus 16 is not 116, so that one's not correct. For our second one, 68% means that we're 1 standard deviation out, so we should have from here to here, we should have a total of 8. And what we've got here is in fact a total of 8 difference between these two. And the mean is halfway between them. And so halfway between, so the standard deviation here is 4, so 4 plus 96 is 100, which will put the mean right where we would need it to be. The other answers are also incorrect. This one's got 97 and it's not one of the numbers, which is 68, 95 and 99.7. This one here, the mean is right, but 68 is 1 standard deviation either way, so if it's the standard deviation is 4, that should be 104, and this one is 2 standard deviations, and so that should be 108. How'd you go? So let's expand a bit on our 68, 95, 99.7% rule. If 68% of all of the x values are contained between these two values here, then the other 32%, so 68% plus 32% gives us 100%. So that 32% is shared equally between the right-hand side and the left-hand side values. And half of 32 is 16%. So we've got 16% of our data values are above the mean plus 1 standard deviation, 16% of them. And 16% of them are below this x value. If we do the same with 95, then we get 5% remaining that's equally spread between the right-hand side and the left-hand side. So spreading 5% equally on both sides gives you 2.5% on both sides. So the probability that our x value is greater than this particular value here is 2.5%. And then finally the 99.7%, if you add 0.3% to that, you get to 100%. So you want half of 0.3%, which is 0.15%, and that goes on the left-hand side and on the right-hand side. And so when you start to add those different sections together and recognize those probabilities, you'll come up with some other probabilities that you can work out. So if we start from the smallest value and we come up to 1 standard deviation above the mean, this blue section contains 84%, or the probability that the x value is in there is 0.84. If you come up to 2 standard deviations above, we've got our 2.5% left over here, which means that this side must be 100% minus the 2.5, which gives us 97.5% on this side. And you can see the same thing on the end here. That's a little white gap. We're missing 0.15%. The rest of it is filled in. So 100 minus 0.15% gives us 99.85%. Let's have a go at some questions with this. Here's some more questions for you to have a go at. So pause the video and then come back. Just be very careful with this. Away you go. Okay, how did you go? So greater than 31 is this section up here. We've got 0.84 down this end, 0.16 up here. For the difference between the two, just add up the two values. For the probability that x is greater than 10, which is this way, given that x is less than 31, which is back this way. Here we need to find the intersection between the two. So we're actually looking for what proportion is in between those two marks there. And when you add them up, you get 0.815, which is your intersection divided by less than or equal to 31. Now, equal to 31 is the probability that it's equal to 31 is 0, so it's just exactly the same as the probability that it's less than 31, because this is conditional probability. Okay, let's have a look at something else. The final symmetry properties that I want to talk about are used when you are not told what the particular value of your x is. You just asked things like probability that x is greater than a is something like 0.2. What's the probability that x is less than a? And of course you do probability that x is less than a. This yellow section here is 1 minus the probability that x is greater than a, which is the blue section here. If your mean is equal to 0 and you've got a and negative a, then this area is the same size as this area, and so the two probabilities are equal. The probability that x is greater than a is equal to the probability that x is less than minus a. And then the final one, if your mean is 0 and you've got a and negative a, and you know the probability of a, you can actually work out the probability that x is between these two values, this pink area here, because the pink area is equal to 1 or 100% minus 2 lots of the probability that x is greater than a. So one lot will give you this and the other one will give you this. I'll show you the sorts of questions that I mean. So this is the sort of question that I'm talking about. X is a continuous random variable that is normally distributed. If the probability that x is less than a is 0.3, probability that x is greater than b is 0.6, and the probability that x is less than c is 0.56, find the probability that x is between a and b, and find the probability that x is greater than b given that x is less than c. Your very first step in solving this should be to draw yourself a little normal distribution showing where a, b and c are situated on the curve given their probabilities. Have a go at that first. Okay, so we know that the probability that x is less than a is 0.3, which means that a is going to be less than the median, because the median has a probability of 0.5. and the median is right in the middle. So it's my very accurate drawing. So our A value is going to be down here somewhere. That's going to be our A. The probability that X is greater than B is equal to 0.6. So that means that more than half of the distribution is above B. So if more than half of the distribution is above B, what does that tell you about the parts of the distribution that are below B? And so where would B go relative to A? And then where would C go relative to A and B? Pop your A and B on here, pause the video and try and work these out. Then come back and compare them with my answers. Okay, let's have a look at how you went. This is the first one. And for the second one, you actually need to work out, so there's A and B. You need to work out the probability that X is in between A and B. And we know that above B is 0.6, so below B is 0.4. We know below C is 0.56, so the bit in the middle must be 0.56, which goes all the way to the end. Take away 0.4, which gives us 0.16. So 0.16 over 0.56. You are expected in exam 1 to be able to simplify these values here, and I know that they're decimals and you generally don't write decimals in a fraction, but to simplify this, multiply both by 100, top and bottom. That will get rid of the decimals, and then divide both by 8 and you'll get 2 on 7. The final thing is to show you how to calculate normal distribution, normal probability on your CAS. So let's have a look at that. So on your CAS calculator, under probability distributions, you'll find normal PDF and normal CDF. Now, the one that we're going to use is normal CDF. The normal PDF is just a shortcut way of storing the actual formula for the function itself, so you won't ever use the normal PDF. So you need to use the normal CDF. And when you open the normal CDF window, it will automatically put in negative infinity as your lower bound. And from there, you'll need to change it. It also automatically puts in your mean as 0 and your standard deviation as 1, and you can just change those things. So when you put the values in, if you don't have a lower bound, like question A, we've got x is less than 5. So we don't actually have a number, specific number, that is the lower bound for our integral. And so we're actually going to use negative infinity. Now, it's already there. If you were looking for it, it's on the pi button. See it here? It's on the pi button. So for this probability here, our lower bound is negative infinity and our upper bound is 5, and that's what I've got here. Our mean was 10 and our standard deviation, be really super careful because that is our variance again. So sigma squared is 4, so our standard deviation is 2. And then when you press OK, it pops out the answer here. And so what I then did, because I've got 2 more questions to do and the mean and the standard deviation aren't changing, what I did was I came back up and I copied and pasted this. So this very first value is our lower bound. The next value is our upper bound. So all I did for the next 2 questions was I just changed those values.